Mr. Strauss's Chemistry Corner was filmed before a live audience. No laugh track was used at any moment during this videotaping, and no animals were hurt. Episode 7, London Dispersion Force Awakens.
Oh my God.
So, we've gone through single displacement and double displacement. Oh, I'm sorry, to my Polish friends again, cześć. And to our Polish viewers, guten Morgen. Because it should be about 7 o'clock right now. So we've done single displacement, double displacement, synthesis reactions.
We haven't done synthesis.
Are pretty simple. Synthesis means to combine, okay? So all you do is take whatever they give you and you plug it together. So suppose I've got, let's try to do something simple here. Okay, this is probably too simple, but let's do it anyhow. Sodium plus chlorine, okay? So the two things are going to combine into one thing. And in the beginning, it's going to be kind of difficult, Hallie, to predict what that single product will be, okay? But after you've done a few million of these, well, 1,000 of these, that's my goal, you guys will be good at predicting the product. So what do you think is going to happen if you combine sodium and chlorine? You're going to get sodium chloride. A synthesis always has one product. Okay, you're going to get one product out. And yes, you guessed correctly, Malgosha, that it's going to be sodium with chlorine. So, would you prefer I use your nickname Gosha? So, write the charges and then balance it. So, one goes here, one goes there. I don't just, when I combine it here, I don't just put the two there. Okay? You've got to rewrite the charges and balance it. Once you have the formula balanced, then you balance the whole equation, Pietro. Okay? So, 2 here. Right, Pietro? 2 here, 2 there. Gives me 2 sodiums, 2 sodiums. All right? Let's see, another synthesis reaction. I think of another good one. Sure. Nitrogen plus hydrogen. Now you may not know what that produces. But again, through doing a few thousand of these, you'll get a better idea. So the nitrogen and the hydrogen will combine to form ammonia. Now, that's the formula for ammonia. You don't need to write the charges and balance it. That usually happens with nonmetal to nonmetal. Okay? And again, there's really no way you're going to be able to know for sure that that's the product unless somebody tells you. So how did I know this? Somebody told me when I was your age. Now I'm telling you. That's how this information gets passed on from generation to generation. So 3 here, I've got 2 there. I got 2 nitrogens here, I'll put a 2 there. And now I'm going to put a 3 there to balance the hydrogens. Is that good, VJ? Yeah? All right, just check it. All right, number 4. Combustion. We did organic combustion, and I'll just review it with you quickly, and then we'll do inorganic combustion. And sometimes reactions can fall into both categories. So combustion is when you react with what? Oxygen. So anytime you react with oxygen, it's combustion. So we've got type 1, which was organic. So organic combustion is when you've got basically carbon, hydrogen, or oxygen. The official, I shouldn't say official, it used to be that the definition of organic was molecules that can only be created by living things. So for example, DNA, blood, saliva, urine, proteins, sugars. Those were only things that could be made by living things, so they called them organic. Versus non-living things like sodium chloride, that could be made by the ocean. So that was inorganic. But around the 1700s, Brandt, I forget his first name, he synthesized urine. He created synthetic urine. And so they realized that you could make organic molecules from inorganic ones. And so they basically changed the definition. Organic now basically means carbon-based molecules. Okay. Wait, no, Brandt didn't synthesize urine. That's wrong. Brandt tried to discover gold from distilling urine and isolated phosphorus. Sorry about that. Brandt did not make urine. I forgot who it was. So, let's see here. So, organic combustion, we did. How about good old? Sure, why not? Propane. Anybody got liquid propane at home to heat their house? No? Okay. So propane is C3H8. React with oxygen. What are the two products you always get out with organic combustion? CO2 and water, right? So we don't have to balance these formulas because they're already balanced for us. And all we have to do, Agnieszka, is balance it all out. Right? So C3, you can send hate mail to C3. 3 goes there. I don't want to send I don't want to give them my real address. So. Yeah, C3, 3 carbons, H8, so I put a 4 there to give me 8 hydrogens. 3 times 2 is 6, plus 4 oxygens is 10, so I put a 5 there, so it's balanced. Type 2 is inorganic, and really it's a synthesis reaction. So this could be synthesis or this could be combustion. For example, magnesium, and we'll do this in the lab, it's pretty cool. You can burn magnesium metal. If you get it hot enough, the magnesium will react with oxygen in the air, it burns super bright, and you just combine the 2 elements. So magnesium is a +2, oxygen's a -2, it's already balanced, so erase the charges. And then I balance the whole equation. So you got a 2 there, put a 2 there, 2 there, it's balanced. Okay? So all you do is just combine the 2. So this could be a synthesis, right? Because I'm ending up with one product, or you could call this combustion. So what will we get out? Iron's a 3+, or iron can be a 2+. So what should we pick, Lukash? 3 or 2?
2.
2?
2.
Okay, Dva it is. So, Jedna, dva, tři, čtyři, pět, šest,
Right.
7, 8, 10, 4.
You don't.
Is that like 1 through 10 or something?
I hope so, otherwise I just insulted someone really bad. So, +2, -2, that's balanced. You could pick either charge. So then we're gonna get a 2 there or a 2 there. All right, the last category is probably the most difficult, and that's decomposition. When you take your quizzes and your test, you're gonna wanna use Appendix E to help you with it, because you're not gonna be able to predict the products offhand. I've done it for a long time, so I can, but you won't be able to. The decomposition, there are 7 major types. We're going to learn all of them, yeah, but I'm going to refer to your appendix. E. This is the second page of appendix E. What I'll do is I'll just give you another example in addition to the one that they're giving you. Okay, so type 1 says you're going to heat a metallic carbonate. Where are the metals on the periodic table? Find the staircase, right? So everything to the left is a metal. So if it's a metallic carbonate, when you heat it, it'll give you the metal oxide plus carbon dioxide. Okay? The triangle means heat. Okay? So let me give you another example. So if we have sodium carbonate. Is that a metallic carbonate? Yes. What will I get out? Well, is there anything else for it to react with? Is there another thing it's reacting with here?
No.
No. That's, the first clue is decomposition, because there'll only be one thing on that side. There'll only be one element, or one compound. So there's nothing else for it to react with. It must be decomposing. It must be breaking down. The question is just, what does it break down into? Well, it's going to break down into the metal oxide, balance it, and carbon dioxide. Those will be the two products. And like I said, there's no way you would have guessed that unless I would have told you. 2 sodiums, 2 sodiums. 1 carbon, 3 oxygens, it's balanced. If you heat a metallic hydroxide, it will decompose into the metal oxide and water. So if you heat a hydroxide, it will turn into metal oxide and water. So let's see, what's a nice, sure, why not? triangle means heat. So what we end up here is, they said metallic oxide, so write the charges. Balance it, it's balanced. And then what's our other product, Giselle?
What?
What's the other product we get out? Oda, Vasa, O.
Okay.
Right? If you don't remember, just look at type 2 on appendix C. Then we balance, one magnesium, 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens. Type 3, metallic chlorate, if they're heated, decompose into metallic chlorides and oxygen. This is the one we did our gum